So hello everyone, I had to cut the video earlier because it's getting quite long. So this is a continuation in resistors in series and in parallel. So previously we have seen how we can solve currents in a simple circuit. So a simple circuit only has one resistor. So now what if we have multiple resistors? So for example, we have a resistor like this, or a resistor like say like this. So we will be seeing how we can simplify this resistor networks. So we want a method to simplify these let's say configurations to a single resistor. Because in that way, we can apply the technique we used in solving a simple circuit. So we just have one battery, one resistor, and we can get the current out of a circuit. So that's our goal. We simplify this sort of complicated connections between resistors into just a single resistor. So let's try to do that. So first we try to analyze what is this kind of configuration. So the first type of connection is series connection. So this series connection for resistors, take note, this is only for resistors. This is the case for resistors. So series connection, only one end of A is connected to B, and connected to C, and connected to C. So only one end. So that means if this is A, only one of its ends should be connected to B. And also one end of B should be connected to C, and so on. D. So now we want to simplify this resistor into one resistor, say resistor AB CD. So in order to simplify this, we need to come up with an equivalent resistance of these four resistors. So in series connected resistors, the equivalent resistance is equal to the sum of the individual resistors. Let's say from I equals 1 to n. So if you have n resistors, you will sum up those n resistors. So for example, here we have we want to solve for equivalent resistance of ABCD. So this is just equal to RA plus RB plus RD. And then next we have parallel connection. So for parallel connected resistors, instead of just one end of A being connected to B being connected to C, both ends of A must be connected to B, and to C, and to D, and so on. So what we mean by both ends, if this is resistor A, So these are its ends. This should be connected to the end of resistor B. So you will see this is the end of A. This is connected to B. This B is connected to C. And so on. So take a serious look on how these both ends are connected in a single wire. So this is the parallel connection. So we want to simplify this connection to just one resistance. So say this is ABC. So for parallel connected resistors, the equivalent resistance is the inverse of the sum of the inverses. R2 plus R plus 1 over Rn, and then take the inverse. So in this case, the equivalent resistance is 1 over Ra is 1 over Rb plus 1 over Rc, then take the inverse. So there are special properties of series connections and parallel connections, and we are going to talk about that in the next video.